Thanks for staying on to listen to my presentation. Just to give you a bit of background, I have worked on Biochoria and I have worked on biomes, but in a very uneven sort of way. In terms of Biochoria, I have done global analyses and I've done analysis on animals and more recently on plants as well. Whereas my biome work is fairly parochial. It's mostly on a Southern African scale. Irrespective of the scale that I looked at when I addressed Biochoria and when I addressed biomes, the conjunction between the two was not something that I had put lots of thought into until 2018, when I saw the review that Ladislav Mutina published on the concept of biome, and it's actually a brilliant review. If you know Lato, you would know that he's extremely knowledgeable. He's a walking encyclopedia, and what's amazing is that he includes references in all languages and nothing really gets left out. What I found surprising in this review was not anything being left out, but something being included, and that was in fact the use of evolution in the definition of biomes, which I had always viewed as being more characteristic of Biochoria. And I responded to his review, and then he responded to my response. I think we had some robust debate there. But what I found surprising when putting together my comment on his review was that I couldn't find a place where there would have been a solid comparison between biomes and Biochoria. So I put together this little slide, which is part of my response to his review. And apart from some obvious differences, such as biomes being more interdigitating and Biochoria being a bit more conterminous, what I'm trying to highlight in this slide is actually that evolution comes in at multiple levels. So all the plants, I'm only referring to plants in this work, but it equally applies to animals. So all the plants that come to be a part of a biome or a part of a biochorion, they come with their own evolutionary baggage, which is older than that biome or biochorion. Subsequently, within the biome, there is diversification. Within the biochorion, there is diversification. What I argue is that, at least in the classical sense of what a biome is, evolution that happens within the biome does not define the biome. So what the biome is, in the classical sense, it's simply defined by plant life forms, physiognomy, and climate, and maybe fire. Whereas in terms of the Biochoria, taxonomic composition is essential, and a better way to define the composition is replacing taxa with some form of phylogenetic information. As was previously mentioned in, I think, two of the earlier presentations in the symposium, we've seen that actually the scale, and more specifically the grain size used in an analysis, can be essential in terms of the boundaries that you come up with. And I would argue that the easiest to separate biomes from Biochoria is on a global scale. The finer the scale you look at, the greater the chances that the two will overlap, and this is probably more so in South America than elsewhere. There was also a mention earlier of Olson et al.'s ecoregions, and ecoregions, I mean, the paper itself barely has any methods. Essentially, they're telling you this is expert knowledge. But my understanding is that ecoregions, the way Olson et al. Propose them, are actually at the intersection between biomes and biochoria. So they essentially subdivide major global regions, which are biochoria, along biome boundaries. This is not always the case. Of course, when biomes interdigitate on a very fine scale, then there are multiple biomes within one ecoregion. This is the most recent global biome classification by Keith and his colleagues, a large number of them, mostly led out of Australia. And it largely stays consistent with previous biome classifications, apart from introducing some finer scale things which would not have been considered biomes in the past. Apart from that, the only major changes are that in some biomes they make the distinction between herbivory and fire. So basically, savanna that's kept as savanna by herbivory becomes a different biome from savanna that stays savanna because of fire. This is the list of biomes that they came up with, and there are a few new ones, and most of the new ones are in Australia, which may appear biased, but at the same time we must remember that Australia is a very special place, and that the factors involved in making a biome what it is in Australia may be different from what they are elsewhere. This is another interesting piece of work looking at variability, climatic variability within biomes, and some are more variable than others. I think it only strengthens the classical biome concept. And then, of course, it's far from exhaustive, but I also want to mention here a few recent works along the lines of biochoria. And this is a very interesting one, looking at spatial congruence. And then the work of White et al. With the motives, which was already discussed by Qin Li. And I think this is really the cutting edge in biogeography, while keeping in mind that motifs are actually not a new concept. And I want to encourage everyone to try to make reference to the original source rather than trying to make reference to articles from the last 5 years. There's also been exciting work in terms of what exactly the boundaries between biochoria represent, what are the factors that create these boundaries, and how these boundaries in fact may have different reasons in different groups of animals and plants. And then, of course, the work of Barnabas Daru, who is basically in charge when it comes to phylogenetic regionalization. So instead of using species in regionalizing the world or sub-regionalizing a region, we use the phylogenetic relationships between those species. And you've got here examples, a map of Madagascar based on phylogenetics, a map of Madagascar based on species. Another example that I think has some potential is ecoregions, along the same lines as what Daru was doing, slightly different methodology. There's also been exciting work about how regions have evolved through time. So essentially, all these last few examples, they're telling you what evolution contributes to is biochoria. And I think there is value in keeping biochoria and biomes separate, not just theoretically, but also from a practical perspective, because conservation has a species aspect and it has an area aspect. The area aspect is primarily working along the lines of biomes and vegetation types, whereas the species aspect, if you want to simplify it, present the species aspect in a geographic context, then the best way to do that is to consider biochoria. So that being said, yeah, thanks again to Andrés for organizing this, and thanks to everyone who is here and listened to my talk. Muchas gracias, muito obrigado, bohomas tutti, xie, dankeschön, vă mulțumesc, sia bonga kakulu, and bye danki, and goodbye everyone.